next section is 5.2, which is multiplication of polynomials. And I want to add an additional vocabulary right here. If a polynomial consists of one term only, these are called monomials. If I have two terms, it is called a binomial. If I have three terms, it's called a trinomial. Everything after these are polynomials. Poly stands for many in Latin. So we do have a separate word for one term, two term, or three term polynomials. The rest are just called polynomials, and that's it. So my first example in multiplication is we will try to multiply monomial times another monomial, and then we'll go up in number of terms that we have and make sure that we don't lose anything along the way. So example number 1, I have negative 8x to the power of 4, y to the power of 7, which is a perfectly good monomial, times 5x to the power of 3, y to the power of 2. This is something that we've seen in chapter 1, because all we're doing is we're multiplying numbers together and adding exponents on the x and adding exponents on the y. So negative 8 times 5 is a negative 40. X to the power of 4 times x to the power of 3, you need to add the exponents, so that becomes a 7. And you have y to the power of 7 times y to the power of 2, so you have a y to the power of 9. In any sense, this will be a little bit easier than chapter 1 multiplication, because you do not see any negative exponents. You have a negative exponents, it is no longer a polynomial. So let's do just a few more of these examples and we'll be ready to move on. Negative 3 a to the power of 5, b c to the power of 6 times negative 4a squared b to the power of 5, c to the power of 8. This is one term, this is one term. There is no plus signs, I'm just multiplying two monomials. Multiply numbers times numbers, a's, b's, and then c's. Negative 3 times negative 4 is a positive 12. A to the power of 5 times a to the power of 2, you add the exponent, so a is to the power of 7. B to the power of 1 and b to the power of 5, you multiply those together, you are adding the exponents. And then as far as c's are concerned, you have c to the power of 6 times c to the power of 8. 6 plus 8 is 14. So there's your final answer in that particular example. Let's move on. My next example is monomial times a binomial. 2t is a perfectly good monomial. I want to multiply this to a 3t minus 5, which is now a binomial because it has 1 and 2 terms. This will work exactly the same way as distribution, so we've seen this before. 2t times 3t is 6t squared. A positive 2t and a negative 5 is a negative 10t. Make sure to attach a negative make sure to attach the sign to the number that it stands right in front of, and you'll never lose it. So positive times negative is negative, and you're done with this particular example. Let's try one more. I have a 3a squared b, which I want to multiply by a squared minus b squared. So a monomial times a binomial. Again, distribution. This term goes here and here. So 3a squared b times a squared. The 3 is still there. The only thing that you need to do is you need to worry about those a's. You have 2 here and 2 here, so that becomes a 4a. Still have that b. Positive times negative is a negative, so I have a minus sign here. I still have my 3, I still have my a squared, and now I need to add the exponents on the b. 1 plus 2 is 3, and I'm done with that example. My next example is binomial times another binomial. Usually we call this the foiling method. First, outer, inner, last. What you want to make sure is you want to make sure that everybody is being multiplied by everybody. So if you treat this as a single entity, you want to make sure that it's multiplied by this and by this. And because this is a binomial and you're multiplying by one thing, you want to make sure that this is multiplied here and it's multiplied here. So this is the process. You take the first term, let me rewrite it with following the letters of FOIL. You take the first terms, I'll use red. Then you take the outer terms. Then you take your inner terms, and then you take your last terms. This is how you know you're not losing anybody. Start with your first term of your first polynomial. Make sure that goes through the second parenthesis. Take the next term of your first polynomial. Make sure that it goes through the second parenthesis. Your goal in multiplication polynomials, you want to make sure that every term is multiplied by every term of the next polynomial. So let's start. Y cubed times 2y cubed is 2y to the power of 6. 3y cubed times positive 4. It's positive 4y cubed. Negative 5 times positive 2y cubed, you have a negative 10y cubed. Negative 5 times a positive 4 is a negative 20. Let's try this foiling a couple more times on smaller examples this time. This is our really first step in factoring, because we'll need to rethink foiling back into what the two polynomials that we multiplied originally look like. So let's do it this way first. So you need to be very comfortable with the foiling method in order for us to start talking about factoring. First terms, x times x is x squared. Follow with the next terms. Positive x times negative 8 is a negative 8x. Inner. Positive 5x times x is positive 5x. Last thing is positive 5 times a negative 8, which is a negative 40. Notice the middle term can be collected, which means that I need to finish this problem right here. So x squared stays where it's at. Negative 8x plus 5x, that's a negative 3x. And then I have my negative 40. And we just finish to collect the middle terms together. You'll have 2y to the power of 6 minus 6y cubed minus 20. Let's do another example. I have 2x plus 3y times x minus 4y. 2x times x is 2x squared. 2x times negative 4y is negative 8xy. Moving on to the next term. 3y times x is a positive 3. Either you write it as a yx or xy. I'll keep it as xy because now you can see that these are like terms. And last, positive 3y times negative 4y is a negative 12y squared. The middle term can be collected. So 2x squared negative 8xy plus 3xy becomes negative 5xy, and then you have your negative 12y squared. Next example. I have a p plus 2 times p to the power of 4 minus 2p cubed plus 3. This is a binomial times a trinomial. Now the idea of this is still the same. You want to make sure that everybody is multiplied by everybody. Just do it very carefully. You start with the p. You make sure that it goes through the second parenthesis. And then you get to the 2. You make sure that it goes through the second parenthesis. Do it very carefully and then collect like terms. P times p to the power of 4 is p to the power of 5. P times negative 2p cubed is negative 2p to the power of 4. P times positive 3 is positive 3p. Moving on to a 2. 2 times p to the power of 4 is positive 2p to the power of 4. 2 times negative 2p cubed is negative 4p cubed. And then 2 times 3 is positive 6. Collect like terms, write them in ascending order. P to the power of 5. Then I have a negative 2p to the power of 4 and a positive 2 to the p to the power of 4. So those are cancelled out. Then you have your p to the power of 3. You have negative 4 of those. Positive 3p plus 6. This is your final example for this polynomial problem. Let's continue. My next example is a trinomial times another trinomial. So 5x to the power of 3 plus x minus 4 times negative 2x squared plus 3x plus 6. So be careful. You need to make sure that 5x cubed goes through the second parenthesis. You need to make sure that x goes through the second parenthesis. And you need to make sure that a negative 4 goes through the second parenthesis. Do it one at a time and be careful. 5x to the power of 3 times negative 2x squared. Positive times negative is negative 10x to the power of 5. You add the exponents. 5x cubed times positive 3x is positive 15x to the power of 4. 5x cubed times positive 6 is positive 30x cubed. X, moving on to the x. Positive x times negative 2x squared is a negative 2x cubed. Positive x times positive 3x is positive 3x squared. Positive x times 6 is positive 6x. Moving on to a negative 4. Negative 4 times negative 2x squared is positive 8x squared. Negative 4 times 3x is negative 12x. And negative 4 times positive 6 is negative 24. I'm almost done. I just need to collect like terms. There's only one of the x to the power of 5, so I'll write it first. It is the highest power. It is a degree 5 polynomial when you're finished with it. I only have one of those 4's, so I have 15x to the power of 4. But when I look at the power of 3 or degree 3 term, I see a couple of them. So I have positive 30, negative 2, so this will be positive 28x cubed. Then I have my x squares. There's a couple of those. So 3x squared plus 8x squared is positive 11x squared. Then I have my x's. So I have 6x minus 12x. That's a negative 6x. And then to finish this off as a constant term. This is the final answer for this particular polynomial multiplication problem. And last example in section 5.2 is how to multiply three things together. In this case, I have a binomial times a binomial times another binomial. What I have is I have an associative property. You can only multiply two things at a time. So pick two things and FOIL. I'll start with the first two parentheses. T times t is t squared minus 4t plus 2t, and then 2 times negative 4 is negative 8. And then I still have the other parenthesis. Collect like terms, you'll end up with a t squared minus 2t minus 8 that I want to multiply by the second parenthesis. Sometimes it's easier to rewrite the smaller polynomial first and then your higher polynomial second. And then continue with your multiplication. Make sure that the t goes through the second parenthesis. Make sure that the 5 goes through the second parenthesis. And you'll be done with this particular problem. T times t squared is t cubed. T times negative 2t is negative t squared. T times negative 8 is negative 8t. Moving on to a 5. 5 times t squared is a positive 5t squared. 5 times negative 2t is negative 10t. 5 times negative 8 is negative 40. Collect like terms. You have your t cubed, negative 2t and positive 5t, negative 2t squared and positive 5t squared is positive 3t squared. Then you have your t's. Negative 8t and negative 10t is negative 18t. And then you have your negative 40.